All right, so this example, we are looking at a one-sided t-test given data instead of the statistics. So it reads, the level of dissolved oxygen in a stream or river is an important indicator of the water's ability to support aquatic life. Scientists know that a DO level between 5 milligrams per liter, below 5 milligrams per liter puts aquatic life at risk. A researcher measures the DO level at 15 randomly chosen locations along a stream. All results are in milligrams per liter. And the data is given as shown. This, of course, is 4.13. So 2 questions. Can we conclude that aquatic life in the stream is at risk using a significance level of alpha equals 0.005? And second question is, given your conclusion, what kind of a mistake could you have made? So once again, we are going to start with state. The mean is the dissolved oxygen level. In milligrams per liter. And our null hypothesis is that mu is 5 milligrams per liter. And our alternative hypothesis is that mu is less than 5 milligrams per liter. For our plan, if conditions are met, we will perform a one-sample t-test with 14 degrees of freedom. All right, so once again, we need to look at random, independent, and normal. So it was given that it was random. Locations are chosen randomly. For independent, there are an infinite number of sampling locations. So the 10% condition is satisfied. And for normal, n equals 15, so we must examine the data. So we're going to use our calculator. And so you can see here that I have entered in the data into a table, and then I've done the 1var stats. Okay, and as you can see, the data has no outliers, no strong skew, and it's roughly normal, so we're safe to use the T procedures. Okay, so as I said, the data has no outliers, no strong skew, and is roughly normal, therefore we are safe to use T procedures. We can also see down here the normal probability plot is roughly linear. Now, if you don't recall how to create that, it's from the same area where we chose the box plot and the histogram. It's just the last graph there. And once again, to set your window to stats, you go under zoom, and then number 9 is zoom stats. Okay, so when we go to do, we're going to use test statistics. And we're going to use data. So from from stats, we go over to tests. And number 2 is t-tests, and we're using data. The mean is 5. We're using our list, and we're going with less than. And so when we calculate, this is what we get. So I'll put that up in a minute, the important data. And if we were to have graphed it, so that's nice to have there. So what we find with our test statistics, we get X bar is about 4.771, SX is 0.940, T is negative 0.9426, and our p-value is 0.1809. So that was from the calculate window that we had. So our conclusion, once again, remember, if we look at our p-value, and if it's greater than alpha, we fail to reject. So that's what we're thinking. And so what we're going to state is the p-value is 0.18, which is greater than 0.05. I think we had 0.005. 3.05. So we will write our p-value is greater than our significance level. So we fail to reject the null hypothesis. There is insufficient evidence to conclude the dissolved oxygen level. So to conclude, the dissolved oxygen level is less than 5.0 milligrams per liter.